This video is about how to factor, and it's something you've gone over for a number of years, but it's one of those tricky things. I know it's very procedural, so I know you could probably use a review on it. Just as a reminder, there are a number of problems worked out in the back of your book as well, and I believe, if I remember right, it's on page 715, but it's one of the checkpoints in the back that has a whole bunch of practice problems, all the answers. So if this is not enough for you, or you just prefer to do that, go ahead and do that instead of watching this video, or in addition to. So let's go ahead and look at a simple example. I want to factor this, which the meaning of the word factor is to take something that is a sum and turn it into something that is a multiplication problem. For all of these, it's going to be two parentheses, each one with an x in it. To come up with those parentheses, some of you use guess and check. Me personally, I use an area model and a diamond problem. I'm not very good at guess and check, so I prefer to do it this way. So, diamond problem first. The two things are going to add to negative 11x because that's the middle term, and they're going to multiply to be 10x squared. I got the 10x squared by multiplying the other two terms. So I'm going to underline in green, those two things are connected, and that red comes from those two things. I multiply the two red things together. That's always the way it goes for that. Then to complete the diamond problem, I kind of guess and check, figure out, okay, what is it going to be? What times what gives me positive 10 but adds to the negative 11? It's kind of weird. I usually start with what multiplies to be 10. That's 5 and 2, and 1 and 10 are the only options. Since I know it adds to be a negative number, they're both going to have to be negative, and negative 1 and negative 10 make that work out. Now I'm ready to fill in the area model because I have everything I need. 2x squared, I always put the squareds in the top left, and the singletons go in the bottom. And these other two, the things I figured out from my diamond problem, go here and in the other box. Negative 1x is the same thing as negative x. Yeah, just write that. So now I have my area model completely done. I need to fill out the outsides though, and that will give me my answer. So figure out what's the biggest thing that comes out of each one. Like in this first column here, what's the most that I can take out of both of those? Well, they both have an x. They also both have a 2. Then how about this other column? They don't really have anything in common. So I'm going to put a negative 1 because they don't have anything in common. Why to put a negative? Well, the top box, the negative x, has a negative in it. And I've just learned that most of the time when that has a negative in it, it just makes sense to pull out the negative as well. Okay, now I can fill out the sides. Both of those have an x in column, and both of these have 5 in common. And again, since the first one's negative, we can put a negative there. Then I double check my answer to make sure my outsides do indeed multiply to be the insides, and checking each one of the 4 boxes, they do. Especially this last box here, the 5, the negative 5 times the negative 1, multiply to be that, that's good to check. Alright, so I have my answer, I just have to write the two parentheses. 2x minus 1 and x minus 5, I got those because those are the two outsides. Let's look at a less simple example. This one's definitely has bigger numbers, and normally that means it's a little bit tougher, but the same procedure still applies. Let me make it over here. Area model, diamond problem. What I want is eventually 2 parentheses. That's what I'm working for. That's what my answer is going to be. I'm going to add to be 4x because that's the middle term. I'm going to add, or multiply to be negative 60x squared. And so I need to figure out what makes that happen. I might have to look around a little bit because there's a lot of things that multiply to be negative 60. I know that one's going to have to be positive and one's going to be negative because they multiply to be a negative. And so you might have to guess and check quite a bit, just like I'm doing in my head right now. 10x and negative 6x are what work out. So now I'm ready to fill in the insides. Hopefully you can see where I got each one of these things. And now I fill out the outsides. In the first column, they both have an x in common. They also both have a 2. Second column, they both have a negative in them. And they also both have a 2. And this is one of these rare factoring problems where there are multiple different ways to factor with this area model. So both of the 10x and the negative 10 have a 5 in common, so I pull that out, and I want to check each box, and it does work. No, it doesn't work. Oh, here, I forgot a 3 out front here. Both of those have a 3 in common, so I want to pull that out. So now the bottom two still work, now the top two work. Okay, so my two parentheses are 3x plus 5 and 2x minus 2. Another way to factor this would be to pull a 2 out first and then to factor, and if you did that, which would actually be a better idea, you would have gotten this. Another way you might have factored it is, I'm just going to try that again. All those are possible answers you could have gotten by factoring, so this is one of these rare ones that there are 3 different ways to do it. You wouldn't have to find all 3 ways, those are just the 3 ways to do it. So go ahead and pause the video and try these on your own. The second, or the one that is I'm underlining right now, I would suggest pulling out a common factor of it first, like all those have something in common, and then factoring what's on the inside, as well as that last one, I would suggest pulling an x out front and then factoring what's left. All right, let's go ahead and see how you did. So let me just copy and paste these. I'll give you some area to put my answers in. So we're looking for 2 parentheses. Man, those are pretty big numbers. Did you have trouble coming up with 2 things that multiplied to be 68x squared and had to be 21x? It's not coming to me right away. Tell me, what'd you get? Can't hear you. Speak up. Oh my gosh, you're making me do it on my own. You're not talking loud enough. I'm all the way in Minneapolis right now, and I can't hear you because you're watching your video in Bloomington. Come on. Well, here, I'm just going to have to do out the diamond problem because this is, I'm not coming up with it on my own. Let's see. Okay, so we need 2 things that multiply to be 68. What multiplies to be 68? 2 and 34. No. 17 and, oh, there we go, 17 and 4. So when you make your area model, you should have ended up with x plus 17 and x plus 4. Erase my diamond problem. All right, the next one, this one's a little bit lower in numbers. However, the negatives, you needed to have one thing be negative, one thing be positive in your diamond problem. And let's see, when you did that, did you get x plus 8 and x minus 6? I hope. This next one here, best idea would be to pull a 2x out first. So then you end up with this that is left. Now you want to factor the underlying part. If you didn't know how to do that, if you didn't know to do this step first, go ahead and pause the video right now and try to factor the underlying part. Here's how to finish it though. 2x, once you figured out how to factor that part, would be x plus 8 and x plus 1. So the final factoring has 3 different factors because I pulled something out and then the underlying part I turned into 2 parentheses. Last one, I would pull out an x first, and then you get x squared minus 16. And again, if you didn't know to do this, go ahead and pause the video and try to factor the underlying part. If you didn't know what to do, or you just did it right now, once you factor, the underlying part factors to this, and so your final factoring again has 3 factors. The order does not make a difference on any of these. I should have mentioned that at the beginning. But for example, if you had in this last one x times x plus 4 and then x minus 4, that is the same thing because of the commutative property of multiplication. The order does not make a difference. So, can you factor? If you can, great. If not, I turn your book to page 715 and look at those examples, run over a few more, or watch the video again, or find some other way to review.
Which was one cool thing Ramsey talked about. He talked about how usually we take Bloom's taxonomy and we enter at the bottom level of Bloom's taxonomy, and then we work our way up. And oh, it's still recording, so you're gonna have to edit.